Imagine two variables, x and y. They are related by a quadratic equation. This could be any quadratic equation, including, our example, y equals x squared plus 2x minus 8. Drawing the relationship between y and x on a graph will result in a curve like this. To start with, we want to understand its shape. Remember, no matter if x is positive or negative, when we square it, the answer will be positive. The bigger x gets, positive or negative, the more massive x squared becomes. This explains why y gets so large when x is large. The next thing to understand is why the curve has a minimum point. Here we also see a way of finding the coordinates of this lowest point, and hence the axis of symmetry. To do so, we remember that we can always express a quadratic in a new form by completing the square. We complete the square by replacing x squared plus 2x with this, which when combined with the minus 8 gives this. So, y equals x plus 1 squared minus 9. But how does this give us the minimum point? We must notice that since this term is squared, the smallest it can be is 0. When squared, any number other than 0 results in a positive number which is larger than 0. This means the minimum that y can be, and the y-coordinate of the minimum point, is given by 0 minus 9, or minus 9. At what x-coordinate does this occur? It occurs when the bracket squared is equal to 0, meaning the bracket itself must be 0. The x value to make this equal to 0 is minus 1, and so the minimum point is found at minus 1 minus 9. This method of completing the square to find the minimum point works for every quadratic. The other points we're interested in are those on the coordinate axis intercepts. To find the y-intercept, we want the y-coordinate of this point here. Since it is on the axis, we know that the x value is 0. To find the y value, we must use a relationship between y and x, asking what is the value of y when x equals 0. And we find this by substituting 0 for x. The constant term is the only one remaining, and so it is the y-intercept. To find the x-intercepts, we want the x values when the y-coordinate equals 0. Subbing in 0 for y leaves us with a quadratic equation. We need to find the x values and so solve the equation, which we can do in this example by factorising. We obtain the solutions and the x-intercept of minus 4 and 2. The quadratic can change, but to find its intercepts you always substitute in 0 for either x or y and then solve the resulting equation.